in section 4.8, I'm going to show you how to use the quadratic formula to find the x-intercepts, or the zeros. So if you have an equation, ax squared plus bx plus c equals 0, this is a normal parabola in standard form that's equal to 0, you can find the zeros, the x-intercepts, using this formula, which you probably already know, negative b plus or minus square root of b squared minus 4ac all over 2a. And what this is really doing for you, it's finding you the two answers. It's finding you where x equals 0. So on a graph, like we calculate the zeros, it's finding those two places where x equals 0, the x-intercepts or the zeros. So let's look at a first example, like x squared plus 3x equals 2. You can't use the quadratic formula yet. This is not in standard form. You have to subtract the 2. Then you can use quadratic formula, so x equals negative 3. That's a, b, and c. Negative 3 plus or minus 3 squared minus 4 times 1, because the 1 in front of the x squared gives it 1. Negative 2 divided by 2 times 1. Simplify this a bit. When you multiply all those things out, you get negative 3 plus or minus square root of 17 all over 2. So this is really two different answers, right? The answers are negative 3 plus square root of 17 over 2 and negative 3 minus square root of 17 over 2. Now, when you use the quadratic formula, you're going to get an equation in this form. If you used your calculator to graph it, obviously it's just going to give you a decimal place for these things. So you should know the difference, and you should know how to relate them as well. So if you use your calculator, let's say it's going to equal out to about 0.56, and this one's going to equal, I don't know, negative 3.56. Let's look at one more example. So negative x squared plus 4x equals 5. Once again, you have to get it in standard form. So negative x squared plus 4x minus 5 equals 0. Then you can put it in the equation. X equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 1 times negative 5 all over 2 times negative 1. Simplify that down to negative 4 plus or minus the square root of negative 4 divided by 2. Sorry, that's a negative 2, because 2 times 1 is negative 2. Okay. Now, the issue here is, we know what the square root of 4 is, but we have a negative square root of 4, and like we learned in the last video, when you have a negative inside the square root, that really gives you an imaginary number. So your two answers are negative 4 plus 2i, square root of 4 is 2, square root of negative 1 is I, divided by negative 2, and you have negative 4 minus 2i divided by negative 2. We need to simplify this a little bit more, because look, you can divide 4 and 2 and 2 and the 2, so we can divide everything by 2. So negative 4 divided by negative 2 is 2. 2 divided by negative 2 is negative 1, so we just get negative I. That's our first answer. And over here, negative 4 divided by negative 2 is 2. Negative 2 divided by negative 2 is plus 1, so plus 1i, or just I. Those are our two answers. We have two imaginary answers. And what it means with our imaginary answers is like this. What this means is the graph never crosses the x-axis. It would have intercepts, but it doesn't actually cross the x-axis. So those are imaginary intercepts, because they don't cross it. The last very important part of this section is what's called the discriminant. Now, in the last chapter, we learned about the determinant of a matrix. You probably remember that because I told you to use determinant of this matrix and get your answer. That is not what we're talking about here. We're talking about this thing called the discriminant. And what this is in this equation, x equals negative b plus or minus b squared minus 4ac all over 2a. This part inside, this part right here, is the discriminant. And you can use that to determine what type of answers you're going to get from the problem. So I'm going to show you this chart from the textbook. Okay, so depending what the discriminant is, you know what the graph is going to look like. So if this value, b squared minus 4ac, is greater than 0, you will have two real solutions, two places where it crosses the x-axis. If it's equal to 0, you have one solution, meaning the vertex lies on the x-axis. It only touches it one time. And if it's less than 0, of course, that's going to give you a negative number, negative r, so negative number underneath that radical sign. And there's no real x-intercept. There are two imaginary solutions because they don't cross. Let's take a look at three examples. So let's say x squared minus 8x plus 17 equals 0. Let's evaluate the discriminant, b squared. So negative 8 squared minus 4ac, so minus 4, times a, which is 1, c, which is 17, equals 0. So that's 64 minus 4 times 1 times 17, which is 68. So we have negative 4, and we need to decide, is that less than 0, is that equal to 0, or is that greater than 0? So negative 4 is less than 0, so we're going to look at our chart and say it's this one. So if we were to graph this using our calculator, we would imagine there to be no real x-intercept, but we'd have imaginary answers. So let's go ahead and try that. So we have x squared minus 8x plus 17. We'll graph it, and we'll see it doesn't cross the x-axis at all, which is what we expected. Let's try another one. So x squared minus 8x plus 16 equals 0. So we have b squared, that's 64 minus 4ac, so 4 times 1 times 16. 64 minus 64 equals 0. So it's going to have one real solution. The vertex is going to be on the x-axis. And the third one is x squared minus 8x plus 15. Once again, we get 64 minus 4 times 1 times 15 is 60. We get 4, which is greater than 0. If we graph it, we expect there to be two real x-intercepts. So let's take a look at that. So we have x squared minus 8x plus 15 graph. It crosses the x-axis twice. We could calculate those intercepts. We could calculate it using the 0. We could calculate it using the quadratic formula. It's up to you, however you want to do that.